Stoichiometry with gases. When we're dealing with a reaction in which the reactant or products are gases, it's usually easiest to specify the quantity of a gas in terms of its volume at a given temperature and pressure. Gases are hard to weigh. You can kind of imagine how that might be difficult. So when we're doing stoichiometry with gases, we can use the ideal gas law to find the amount in moles, or we can sometimes use the molar mass, the molar volume of a gas if it's at STP. But we can calculate number of moles if we're given volume and temperature. We can calculate volume if we have moles and temperature. If you have STP, go ahead and use the molar volume, 22.4 liters. By the way, this funky wooden box here is GMV, gas, molar volume, 22.4 liters. So this guy is 22.4 liters in volume. That's 1 mole of a gas, if you're interested, or not. The pressures in these reactions could also be partial pressures. And so here's kind of a general conceptual plan. If you've got mass of A, you can go to amount of A in moles to mass. This is the general idea of stoichiometry that we talked about, grams to moles to moles to grams. With gases, you're going to have pressure, volume, temperature of a gas. You can go to moles of that. You can go to moles of the other thing, and then pressure, volume, temperature of a second gas. So let's do an example. How many grams of water form when 1.24 liters of gas H2 at STP completely reacts with O2? Okay, just overlook the bad, I don't know if it's grammar or what, there's something wrong with that sentence, that's fine. 1.24 liters of H2. I think if we just get rid of, let's try something more effective. If we just get rid of that, we'll be 1.24 liters of H2 completely reacts. There, that fixed the sentence. So we have 1.24 liters of hydrogen at STP. That's important. At STP. And the question is how many grams of water? So over here, water, question mark, we want grams. Yes, it's a gas, but the question asks us for grams. So then our path, we're starting with a volume of hydrogen. So our path is liters of H2, and we always go to moles in the middle. Moles of H2 to moles of O2. No, not O2. That's not what we want. We want H2O. To grams of H2O. Now, do you have to write that down? No, but if you get lost easily, go ahead and write it down. Here we've got liters, so we can just start doing our equation here with dimensional analysis, 1.24 liters of H2. We've got 3 arrows, we've got 3 conversion factors, we'll go to moles of H2. We'll go to moles of H2O. We'll go to grams of H2O. And then we put the units from the previous term underneath. Moles of H2. Moles of H2O. We get all the units to work out. The one in the center is always the easy one. Coefficients, 2 before the H2, 2 before the H2O. Moles of hydrogen per liter of hydrogen. At STP is the key here. What is this relationship at STP? 22.4. And just like a molar mass where it was 1 mole, this is molar volume, it's 1 mole, and the 22.4 goes with the liters. This is molar mass. 1 mole. 1 mole of water weighs 18.02 grams. 1.24 divided by 22.4 times 2 divided by 2, those are going to cancel out, times 18.02 equals, how many sig figs should I have? 3.998. It's 7.5, but it rounds out to 8 grams of H2O. Put a box around it and tie it up with a bow. Any questions? So many variations that could be done with that. Oh, here's another one, more words. Engineers use copper in absorbent beds to react with and remove oxygen impurities in ethylene used to make polyethylene. Oh, that's all very nice, but we don't need to know that. The beds are regenerated when hot H2 reduces the copper to oxide, forming the pure metal and H2O. What volume of H2 at 765 torr and 225 degrees Celsius is needed to reduce 35.5 grams of copper to oxide? Doesn't that look fun? No cheering? No, that's okay. We need an equation, don't we? We've got a reaction going on here. They're giving us information about volume of hydrogen. They're giving us a pressure and a temperature. They're giving us a mass of this thing. This amounts to a stoichiometry problem. So here is the word version of our reaction. H2 reduces the copper to oxide, forming, that's where the arrow is, come on, forming the pure metal and H2O. So we've got H2 reacting with copper 2 oxide. That's Cu2 plus and O2 minus, so it's going to be CuO to form the pure metal. What pure metal? Copper and H2O. So we need to balance this equation. It's already balanced, isn't it? It's a little unnerving when that happens, isn't it? You're like, wait, it can't be that easy. Could it really just work out like that? It just worked out like that. Cool. It's like a present or something. Now we can use this to organize the rest of this mess. This mass here is the copper 2 oxide. So 35.5 grams, I'm going to write that underneath, 35.5 grams of that. And what volume is the question. What's a good volume unit for gases? Liter. So we'll just decide on liters there. And then we've got this information, torr and Celsius. So 765 torr, 225 degrees Celsius. So H2 is what we're being asked about. That means we're starting with this one. So our path is going to be grams of CuO, always to moles in the middle, to moles of CuO, to moles of H2, to liters of H2. .5 grams of CuO to moles of CuO. grams of CuO go down there. And the next one is moles of H2, moles of CuO goes down there. And then we want liters of H2 and moles of H2 go down there. This is the mole ratio, which in this case is 1:1. So that's pretty straightforward. Molar mass of copper 2 oxide is 63.55 plus 16, which is, 79.55? 79.55 grams. What do we do here? We use 22.4? Please say no. Somebody. No, we can't. It'd be fun. It'd be easy, but we can't. Why? It's not at STP. Is there some nice little thing we can stick in here? Not really, huh? We need to use PivNert. PivNert doesn't really fit into our dimensional analysis thing very well. I saw this coming and I went there on purpose. I seriously did. So we can't really throw that in there. So at this point we're going to stop at moles of H2 and figure out how many moles of H2, and then we're going to use PivNert to figure out the rest. 35.5 divided by 79.55. 0.44626. 3 sig figs moles of H2. So we need to use PivNert and find the volume in liters. So if we take PivNert and rearrange it, volume equals nRT over P. Well, our pressure and our temperature are not what we need them to be. So 765 torr, should have left room, but I didn't. 1 atmosphere. So 1.0066 atmospheres. And the temperature is 225 plus 273.15. 498.15 kelvins. Okay, that's what we need. So then way up here, we've got our number of moles that we calculated from the reaction. And we've got R. And T. And all of that's divided by the pressure and the volume will come out in liters then. Should have 3 significant figures. It'll be 18.1 liters. Any questions? Properties of gases. Can't remember why this is in here, but there it is. Look at that. They expand completely to fill their containers. They take on the shapes of their containers. They have a very low density, much less than solids or liquids. Solids and liquids are fairly close in density. Gases much, much less. Gases are compressible, and mixtures of gases are always homogeneous.